Hello everyone, thank you for your patience in waiting for me to get Friday's lesson posted. So today I want to kind of quickly cover a couple of things that I've posted up for you for the end of Chapter 2 assessment. So if you head over to the Moodle page and into the end of chapter assessments, I've posted a couple things up here for the second assessment, which is going to deal with all of the things that we've been working on with regards to topics and place value. So specifically, you want to take a look at the PDF and the Word document. So if you click on the PDF, the general instructions for the assessment are going to come up. The assessment is going to be a video assignment. So you're going to record a 3 to 5. It can be a little bit longer if it needs to be, but it's probably going to try to aim for around that 3 to 5 minutes to work through a question, and then you're going to upload that video to either YouTube or to the Moodle Dropbox, whatever is easiest for you based on what you use for recording. So the front page here just goes through some of the logistics, gives you a couple programs to take a look at. If you're using a laptop, you can use your smartphone as well and just kind of like record you doing some work on paper. That's totally fine. And then once you have that video ready to go, you can upload that to YouTube or directly to our Moodle Dropbox, whatever is easiest for you guys. If you upload it to YouTube, just copy the link to that video and make sure that link gets to me in some way inside the Moodle Dropbox. What students usually do is they will usually just copy the link and they'll paste it onto a Word document, for example, then upload that Word document to the Moodle Dropbox. Okay, so I don't think there's anything else exciting here. So this, the second page of the PDF describes the video assignment in a little bit more detail. So there's two different choices you can do here. You can either do a video on Base-5 addition, or you can do a video on Base-5 subtraction, whatever your preference might be. Excuse me. So the first one, for example, is setting up a stacked addition using the following two Base-5 numbers, 1203 and 1442. And the goal is to not only work through the addition using some kind of algorithm, but also show that as a representation. So if you're using like a laptop or you're going to be writing stuff down on paper, you're going to be using some of those Base-5 blocks to explain what's happening inside of your algorithm. You don't have to necessarily cover Base-5 blocks in general. This video is kind of for me to double check your understanding of how this works. So I already know that there's units, there's 5 blocks, there's 25 blocks, and there's 125 blocks. You don't need to explain that to me. It would be more along the lines of, if you're doing a certain step inside the algorithm and you have to carry a 1 or you have to borrow from a different column, you're going to want to show that to me in a visual kind of way so that I understand that you get how to connect the algorithm to the Base-5 blocks. So that's really the key of the video assignment. It shouldn't take you, I don't think it should take you much longer than 5 minutes to explain this and connect it to a picture of some kind. And my recommendation, what students have done for me in the past, is they'll choose one of these, they'll kind of write out a little script for themselves, and then they'll just kind of follow along the script as they record their lesson. If you do have any questions over the weekend, feel free to email those and I will get back to you if you have any questions about the overall assignment. Now, I have put a tentative due date as March the 7th. However, the Dropbox will stay open until March 10th. So I know some of you said, yeah, the Sunday's fine. I can get it in by March 7th. That's cool. But the final kind of cutoff date for uploading is going to be March the 10th. So put one of those due dates inside of your calendar and make sure you get the video uploaded sometime before the 10th. So that gives you all of next week to kind of start thinking about how you want to do it. And to be fair, I mean, if you put a little bit of work into it next week, it shouldn't take you that long to do. It should maybe take you maybe a half hour at most, because I think most of us were pretty comfortable with addition and subtraction. But yeah, put a little bit of time in if you have the time next week before your midterm starts, so you can kind of get ahead of the game here and just get that out of the way. Now, the second item that I've uploaded here for you, just let me go back to the folder. So the second item that I've uploaded is the rubric that I'm going to be using. So I'm just going to pop that up here on the screen. There are no definitive mark breakdowns like I had for the lesson plans. So the lesson plans had like a number to go along with all of the rubrics. Here I just have a bunch of different topics that I'm going to be kind of highlighting on, and I'm going to give comments kind of at the end, and I'm going to give you just kind of a rough score out of 100, rounded to what I think is like the nearest 5%. So like a 90, 95, a 100 if it's super exceptional, things like that. I'm not really going to be super picky about getting it down to the exact percent. I'm going to kind of give you a rough mark based on how I think you compare with the rest of the class. Yeah, so that's up there for you guys to take a look at over the next few days. And if you do have any questions, we can definitely talk about this a little bit more on Monday if that's something that you want to do. So for the rest of the day today, or the rest of the lesson today, we're going to work a little bit on Base-5 Division. So I have just 2 examples I would like to cover with you guys. So you have a few examples of Base-5 Division in your notes as well. Okay, so similar to base 10 division, what we're going to do is we're going to set up the problem and we're going to look at it from a partitive division kind of perspective. Okay, so we're still going to use that partitive or fair share model to model a base 5 division. So in other words, if I'm looking at, this should say EX, so if I'm looking at the following example, 214 in base 5 divided by 3 in base 5, and I want to kind of think about what the visual looks for this particular problem. What we're going to do is maybe I'll just kind of divide our page in half, and we'll do the model part over on the left, and we'll do the algorithm part over on the right. So normally what we would do for the algorithm is we would take that first number, we put that inside our soccer fence, and then we put the divisor, the number that's we're kind of trying to fair share into as outside of the half soccer goalpost is what I used to call it in grade 4. For the model, what we're going to do is we're going to model the total number of objects we have. So we're going to model the quotient. Wait, is that the one that I want? What are the parts? I need to remember the parts of a division statement now. I think I'm saying the wrong thing. I think quotient is the answer. The dividend, right? I think the dividend is the word that I want here. I think it's the dividend. Yeah, I feel more confident. I think the quotient is our final answer. This is going to be, we're going to model the dividend. Okay, so the dividend is 214 in base 5. So that means we have 4 units. We have one 5 block, and we have 2 25 blocks. So we model the dividend. We're not going to model the divisor. The divisor is actually going to get modeled as the number of equal-sized groups that we're trying to break up these units into. So we're going to model 3 groups. Okay, so our divisor becomes the number of equal-sized groups that we're trying to fair share into. And then we're pretty much set up and ready to go. So from here, we want to now go back over to the algorithm and try to figure out what step we would do first. Now, normally we would take this number 3 and we would ask ourselves, how many times does 3 go into the number 2? In other words, I'm looking over here at the two objects that I have and trying to determine if I can fair share them into 3 equal-sized groups. Well, we're kind of shit out of luck here because we have 2 objects, 3 groups. I can't fair share them. So what we would do next is we would extend that question that we initially started with. So now we're looking at both the 2 and the 1. And we ask ourselves, how many times does 3 go into the number 2, 1? So essentially what we've done to start this problem is we've actually broken apart these 25 blocks into individual 5 blocks. And we should have 21. No, that's not right. I lied. We should have, 5, 10? We should have 11. I'm sorry. We should have 11 5 blocks after we break these apart because the number 2, 1 in base 5 is 11 in base 10. So I'm going to do that as the first step. So just let me kind of erase a couple things here. Got to get that afternoon Java going. Okay. So we're going to break apart those 5 blocks so that now we have 1, 2, 3, 4, 5. 1, 2, 3, 4. Or break apart these 25 blocks. My apologies. 2, 3, 4. Okay, so here's our new number that we're working with. And we really haven't done much over here other than say instead of dividing into instead of dividing 2 into 3 groups, we're now looking at dividing 2, 1 into 3 groups. Okay, so is it possible for us to now start distributing some of these 5 blocks into our 3 equal-sized groups? I think we can do that. So we're going to start counting up. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, 11. We're going to have 2 leftover 5 blocks. Okay, so 1, 2, so I'm going to start kind of crossing them off. 1, 2, 3, so 5, 6, 7, 8, 9. So we're going to have 2 left over. Okay, so since we're working with division, remember that the number that we put on top of the number 1 is going to represent the number of 5 blocks that we got into each group. So we were able to get 3 5 blocks into each group. Now, the hard part about doing division in base 5 is now we need to do this subtraction step, and we need to do all of this in base 5, unfortunately. So if you need to, go back to your base 5 times tables, because we need to do 3 times 3. 3 times 3 is 9, and 9 in base 5 looks like this. Okay, it looks like the number 1, 4. Okay, so this number 1, 4 represents the fact that we've used up 9 5 blocks in this particular step. Okay, when I do this subtraction step, I hope that I'm left over with 2 because that's the number of 5 blocks that are actually left over. So doing this subtraction, we would technically have to borrow. We get 6 minus 4, which is 2, and then 1 minus 1, which is 0. Perfect. So that's the first step. We break up our 5 blocks into smaller pieces because we couldn't distribute them nicely. Then we distribute as many 5 blocks as we can, and then we're left over with these 2 5 blocks. So that's step number 1. So now we're going to go through the regrouping phase. And we're going to do the same thing. We're going to break down these two leftovers. So this 2 represents the leftover 5 blocks. So let's go ahead, let's break these 5 blocks down into their individual units. Okay, and our groups really haven't changed. We still have 3 groups altogether, and each of those 3 groups still has 3 5 blocks inside. So moving from what we just had to down here is kind of like this action of bringing the 4 down, if that makes sense. So when I go to bring this 4 down in this particular step here to get to 4 base 5, that's the action of kind of regrouping the leftover 5 blocks into units. So now I have 2 4 units altogether. Okay, so this 2 4 represents the number of units we have, which is 14. Okay, we should now be able to distribute these units into the equal-sized groups. So that's what I'm going to do down here. We're going to distribute some units into these 3 equal-sized groups. And we're going to see how many units we can get into each group. Okay, so I have 14 altogether. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so I'm able to actually get 4 units into each group, and I'm going to be left over, is that right? Left over with 2. Okay, so we were able to get 4 unit blocks into each group. That's what this 4 represents. Okay, how many unit blocks did we use altogether? Well, we used 12. Okay, 12 in base 5 is 2, 2. And subtracting, we should get 2 leftover units. Okay, so this 2, 2 represents the 12 units that we used in this step. And this number 2 represents the leftover units that we were unable to distribute nicely into these 3 equal-sized groups. Okay, and from here we can summarize. We can say that our answer is 214 divided by 3. We get 3 base 5 blocks and 4 units in each of those 3 groups, with a remainder of 2 units that we're unable to distribute into those 3 groups. There's our final answer, 3 4, with a remainder of 2 units. Okay, so that is an example of, if the second number you get is small enough, you can probably actually just model it over on the side. The hard part I find is kind of figuring out how many times the number will go into this larger number. So it is actually quite helpful. We'll do another example here. It's quite helpful to actually list your multiplication tables over on the right-hand side. So an alternate strategy is to use your times tables. So let's look at the example of 3, 4, 4, 3 divided by 1, 2. Okay, so we're going to divide by the number 7 essentially. And in green, I want you to kind of, we're going to think way back to, like what would I do if I actually had this number divided by this number in base 10? Well, I was really not that great with my 12s times tables, so usually what I would do when I was working on these division problems is actually list out some of the multiples of 12 over on the right side. So 12 times 1 is 12, 12 times 2 is 24, 12 times 3 is 36. So not only is this a helpful thing to do with your students because it gets them used to skip counting, right, and recognizing some of the important benchmark numbers, it's also a way that we can kind of reference and see what we need. So when I go to do this division, I'm looking at, the number 34. How many times does 12 go into 34? Does it go 3 times? No. 3 times is too big, so we take the next smallest number. So it's going to go in 2 times, and 2 times 12 is 24, and that means there are 10 leftover objects at this particular step. Okay, then we bring down the 4, and now I have to get as close as I can to 104 without going over. Okay, well, the next few multiples are 48, 60, 72, 84, 96, and then it would be 108, I think. Is that correct? Yes, I think that's right. So 108's too big. So that means 1, 2, 3, 4, 5, 6, 7. So 12 times 8 should work in this step. So this is what I mean by if you have like a nice list of multiples, or if you have your times table kind of over on the side, you can kind of reference that times table to help you work through this problem, right? I've already done this, so now I know 8 times 12 is 96, and I have to subtract. So let's see, we're going to borrow from here and get a 14, and I believe that's 8. 8 and 6 is 14. And then our last step is to deal with the number 83. Now 84 is too big, so we're going to have to take 6 here, and then we get 72, and we do our last subtraction here to get 11. Okay, so the answer here, if I were to do this in base 10, would be 286 with 11 remainder units. So that kind of strategy is the same kind of strategy I want to approach for this particular question in base 5. Let's write out our 12 or our 7 times tables in base 5. Okay, obviously 1, 2, or 7 times itself is still 1. What about 7 times 2? 7 times 2 is 14. Okay, and 14 looks like this. Right? 2 5s plus 4 leftover units. Okay, what is 7 times 3? 7 times 3 is 21. That's going to be 4 5s and a leftover unit. And then finally, the last one we need, because we're working in base 5, we only ever have to go up to our 4th times table. We need 7 times 4. 7 times 4 is a hard one because it's the number 28. And the number 28 is 25 plus 3 units. So it's a 25 block, 0 5 blocks, and 3 units. That's a tricky one. Okay, so hopefully you can follow that idea. But now that I have my 12 times table, I can tackle this without having to draw the model, right? I mean, I could tackle this by trying to draw out all the blocks, draw 7 equal size groups, and try to distribute, but I think that's going to start to get a little clunky if there's a lot of groups. So I sometimes prefer using the tables like this. And so now we should be able to tackle this in a fairly straightforward kind of way. So let's look at 3, 4. Which multiple, okay, so which of these numbers over here, which multiple gets us as close as possible to 3, 4 without going over? Well, it's going to be the second multiple right here, because the third multiple gives us a 4 in the first place value, which is bigger than 3. So I need to take the second multiple. Okay, so I'm going to write that down here. Take the second multiple, and the second multiple of 1, 2 is 2, 4. And when we subtract, we're going to get 1, 0 left over. Okay, obviously 1, 2, we can't divide these leftover things into 1, 2 groups. So we need to bring down the number 4. And now we're going to think about, okay, how close can I get to 104 without going over? And it turns out that we can get pretty darn close, right? We can actually get to 103, right? And that's the fourth multiple of the number that we're working with. Okay, so I'm going to put a 4 up here because I know that 4 times the number we're working with is 103. Okay, we're going to subtract this to get 1 leftover unit. Okay, and finally bringing down the number 3. The closest we can get to 1, 3, or the number 8, is by using the first multiple of 7, which is 1, 2. Okay, and that's going to give us 1 leftover unit. So that's how we use a multiplication table to do some work for us. If you want, just remind me on Monday, we can work through a couple more examples if you would like. But we do have to start kind of working our way into the next chapter, which is working a little bit more with prime numbers, and we're going to learn how to do some mathematics with dividing numbers and stuff like that. It's actually kind of a fun chapter, a little more kind of, I would say, like lighthearted compared to some of the base 5 stuff we've been doing. So final answer here is that 3, 4, 4, 3 in base 5 divided by 7, or 1, 2, should be the number 2, 4, 1 in base 5 with a remainder of 1 unit. So if I had to model this, I'd have 7 equal-sized groups. I would have been able to get 2 25 blocks, 4 5 blocks, 1 unit into each of those equal-sized groups, and then I have a leftover unit that I just wasn't able to get into those 7 equal-sized groups. So I would say if you want a little bit of extra practice, you can maybe try this example again using the partitive model to see if you can understand how the partitive model fits into all of this. And same thing up here, you know, you can scroll back and you can maybe work on this question one more time using the times table approach. So list out your 3 times tables and see if you can work through this problem again using your 3 times tables. Just so you are aware as well, I have posted some extra practice inside of this chapter 2. So if you do want a little bit of extra practice with base 5 multiplication or subtraction or addition or division, there are some worksheets up here for you to practice over the next couple weeks, because you probably will get asked to do some of this stuff on the final exam. So yeah, so that's there for you if you need it. Okay, that is it that I would like to show you inside of the place value chapter. So our next focus, like I said, is going to starting to work with prime numbers, greatest common factor, lowest common multiple. And that's what's coming up next week. So have a lovely weekend, and I will see you all on Monday.